All right, today we're going to be talking about intercept form. So we've already looked at standard form, which is in the form ax squared plus bx plus c. And we've looked at vertex form, which is f of x equals a times the quantity x minus h squared plus k. And today we're going to be looking at a new form called intercept form, which is f of x equals a times the quantity x minus p times the quantity x minus q. So each of these forms you're going to have to know which one to use and when to use it. And so each one has their own specific thing that you're going to want to be looking for. So in this case, standard form is just your standard form. You're able to graph that using the formula for axis of symmetry to find x. And then the vertex form, you're given the vertex, which is h comma k. So you can use the vertex and then find some other points and plug those in. And the intercept form, now you're going to be using the x-intercepts. So right here, x minus p, p is an x-intercept. Okay, and this is where the x-intercept it lies. So this one lies to you. Okay, because if it's in parentheses, remember it's opposite value. So if it's x minus p, our x-intercept is going to be p comma 0. So it's going to be on the x-axis at p comma 0. If it was x plus p, it would be negative p comma 0. So that is a helpful hint where if it's inside the parentheses, we always do the opposite of what it says. So this one, q, is also an x-intercept. So this has two factors which give us the x-intercepts. Same thing, it lies to us because it's opposite sign of what's inside the parentheses. So for this one, it's q comma 0. If it was x plus q, it would be negative q comma 0. All right, so let's take a look at some examples. So first we're going to look at the axis of symmetry. Remember, the axis of symmetry is always halfway between those x-intercepts. So those 2 points that are on both sides of the vertex that create the parabola, that is where your x-intercepts are, and we always know that the axis of symmetry splits that right down the middle. So to find the axis of symmetry, since it is halfway between the two x-intercepts, we're going to add the two together and divide by 2. That's what we do when we want to find the average, or when we want to find the mean of it. We want to add it together and divide it by 2. So if I give you an example, we have y equals x plus 6 and x minus 4. My p is going to equal negative 6 because it's opposite of what's inside the parentheses. And my q is going to be positive 4 because it's opposite of what's inside those parentheses. So now that I know what p is and I know what q is, I can plug that into my axis of symmetry formula. And I get x equals negative 6 plus 4 divided by 2. So p is negative 6, q is 4. I'm going to divide that by 2, so I'm going to add those two together. Negative 6 plus 4 is negative 2 divided by 2, and that's going to give me negative 1. So my x value of my axis of symmetry is x equals negative 1. Now remember, to find the vertex, we still need to find the y value because we have the x value. Now we need to find the y value. So we're going to plug in the x value from the axis of symmetry to find the y value back into the original equation. So y equals, we have x plus 6 times x minus 4. So I'm going to plug in negative 1 for x plus 6 times negative 1 minus 4. So then y equals negative 1 plus 6 is 5. Negative 1 minus 4 is negative 5. So my y value equals negative 25. So the vertex is going to be at negative 1, negative 25. And that's it. That's how you find those. And then when we graph, we're going to use the x-intercepts to graph. We don't have to find any other points. We use the vertex, we use the x-intercepts, and we can graph those points, draw the parabola, and we're done. Okay, so let's try it. Number 1, we have y equals negative x plus 1 times the quantity x minus 5. First, I want to find what p and q are. So let's figure out what p equals. So here, it's plus 1, so p is going to be negative 1. Q equals, it's minus 5, so it's going to be positive 5. I need to find the axis of symmetry, so I'm going to do x equals, remember, it's p plus q divided by 2. So I have negative 1 plus 5 divided by 2. Negative 1 plus 5 is positive 4 divided by 2 is going to give me 2. So x equals 2. Plug in x back into the original equation. So it's going to give me y equals negative. So I'm going to plug in x, these x values right here back in the original equation. So 2 plus 1 times 2 minus 5. So y equals negative 3 times negative 3. So I have a negative times a 3 times a negative 3. And if I multiply those all together, negative times 3 is negative 3 times negative 3 again is going to give me a positive 9. So now I have 2 comma 9 for my vertex. So I can start filling in this information down here. So my x-intercepts, let's go back up to p and q. Remember our x-intercepts, we're going to write those as negative 1 comma 0 and 5 comma 0. Remember, these are x-intercepts. We cannot write negative 1 comma 5. That's not the way it's written. Otherwise, that's not going to be x-intercepts. X-intercepts have to be on the x-axis, and negative 1 comma 5 is not there. So you cannot write our x-intercepts like that. That's just 1 point. We need 2 that are on the x-axis. All right. At the axis of symmetry, we got to be x equals 2. Yep. And then our vertex is 2 comma 9. So let's plot what we know already. So 2 comma 9, I'm going to go over to 2. I'm going to go up to 9. Okay, there's your vertex. Then I'm going to plot my y or my x-intercept. So negative 1, 0 is going to go on the x-axis here. 5, 0 is going to go on the x-axis here. Remember, my axis of symmetry goes down through the middle right here. Does it cut that directly in half? Are the x-intercepts equal distance from the vertex? So this right here is 3 units away. This is also 3 units away, so it does cut it directly in half, and we know we are good. So now we can draw the parabola. And now we can answer our question, is it a maximum or minimum? It's a maximum at y equals 9. And I'm going to add something here. What is the domain and what is the range? So the domain we know is always all real numbers. And the range, because it's opening down, it's going to be y is less than or equal to 9. It's always the x or the y value of the vertex. All right, so that is how we do it. We don't really have any extra work to do. We just have to know what those x-intercepts are, which we're pretty much given if we look at the equation. And then we need to find the vertex, and we can graph it. So if we look at number 2, we're going to try this one. If you want to pause this video, I want you to try this one on your own. And then you can come back and look at it. So if you pause it, I'm going to still work through it. But I really would like you to pause it and try to work through it on your own first and see if you're on the right track. This is the only way that you're going to learn. So here we have P equals, because it's minus 3 here, it's going to be positive 3 over here. Q equals, because it's plus 1, it's going to be negative 1. Use the formula, P plus Q divided by 2 to find what X equals. So 3 minus 1 divided by 2 is 2 over 2, which equals 1. So my X equals 1. To find Y, I'm going to plug it back in. So Y equals, I still have a 2 up front. I still have to keep that 2. 1 minus 3 and 1 plus 1. So Y equals 2 times negative 2 times 2. So Y equals negative 8. So now I have my vertex of 1, negative 8. My axis of symmetry is X equals 1. And if I go back up and look, my x-intercepts are 3, 0 and negative 1, 0. Graph the vertex and the intercepts. So 1, negative 8 is down here. 3, 0 is right here. Negative 1, 0 is over here. It's 2 units away from the axis of symmetry, so I know that it cuts it directly in half. I can draw my parabola. I know my parabola is going to open up because this is positive, positive 2. This one opened down because it was a negative over here, so that's negative. Means that it's going to open down, so I know at least graph those right. This one's going to be a minimum at y equals negative 8. Domain is all real numbers, and your range is going to be y, because it opens up, it's going to be greater than or equal to negative 8. And that's it. So those are pretty quick. They go by fast. You should be able to do those fairly easily on your own. All right, the next ones we're going to spend some time looking at, because these are the ones that you actually have to factor, because they're not in intercept form. They're in standard form. So in order to get them from standard form to intercept form, we have to factor these out. So remember, first thing we're going to do is look for greatest common factor. Is there a greatest common factor? In this one, yes, we can take a 2 out of each of those numbers. So if I take a 2 out, I'm going to get y equals 2 times the quantity x squared minus 2x minus 6. And this is the part you really want to pay attention to. So if you guys come back and tell me you didn't understand, it's because you did not work through these and you didn't try to understand them. This is everything that we've already done. It's just putting it all together as one. So it's prior knowledge. We've already tested on factoring. And so this is, we're not doing anything different except putting it together with new skills. So now that we have y equals 2 times the quantity x squared minus 2x, oops, I did that wrong. That should say minus 3. Now we can factor x squared minus 2x minus 3 into two factors. So what are those two factors? Remember, factors of negative 3 that add up to be negative 2. So what are factors of negative 3 that add up to be negative 2? So in this case, we're going to have negative 3 times positive 1. And negative 3 plus 1 is going to give me negative 2, and that checks. So I'm going to have x minus 3 and x plus 1 as my two factors. Now I have something that I can actually use the intercept form for. I have my two factors. So I can pick out my P and Q. So P equals, since it's negative 3 inside the parentheses, it's going to be positive 3. Q equals negative 1. Can those be mixed up? They can be. If you would have put x plus 1 and x minus 3, it doesn't matter. P and Q are the intercepts, so it doesn't matter which order that they're in. So we're going to find what x equals. So we're going to do 3 minus 1 divided by 2 is going to be 2 divided by 2, which is equal to 1. Plug it in for y. Y equals. You can either plug it into the original or plug it into the intercept form. I'm going to use the intercept form because it's easier to calculate. So I have 1 minus 3 times 1 plus 1. So y equals 2 times negative 2 plus 2. So y equals negative 8. As we're doing this, what do you notice? Let's look back. If you notice, it looks like the last problem that we just did. It's going to end up looking like this. So it's exactly the same one. 2, x minus 3, x plus 1. It has the same factors. So I'm not going to work through all of this because we already did it, but I wanted you to see that this is the same thing. This is in standard form, and we had to put it into intercept form, so we had to use the factors. And it works out exactly the same way. Okay? All right, so that one we already had done. Number 4, we're going to skip through that one. We're just going to do the factors, and then we're not going to go through the rest of that because you guys already have the rest of that down pat. You should already know what the axis of symmetry and the vertex and how to find all of that. So let's just factor this one. Y equals. So this doesn't have any greatest common factor, so there's nothing that we can factor out first. So we can just find our two factors of it. So remember, we need numbers that multiply to get to 14, but add to get to 9. So we have 7 and 2, and that works. X plus 7, x plus 2. So now that I have my two factors, I can pick out P. So P is negative 7. Q is negative 2. Solve for x. X equals negative 7 minus 2 over 2. This one is going to give us negative 9 over 2 as our x value. Do we know where that is? Do we know what x is? Negative 9 over 2. Can we find that on the graph? How would I find that? Well, this one I would have to just divide out, and I know that x equals negative 4.5. I can figure that out. So it's okay to have fractions. We're able to still graph those and figure out where those are on the graph, so we can still find that. And then you can plug that in and solve for y. I'm not going to go through all of that with you. But I can tell you that y is equal to negative 25 over 4 if you want to try it on your own and see what you got. All right. Going down to the bottom parts, we have f of x equals. So what we're trying to do is find the zeros. We're already familiar with this. We've done this several times when we were graphing and factoring. So if we look at this, we have f of x equals x minus 5 and x plus 4. To find the zeros, remember, we're looking for the roots. These are also called the x-intercepts or solutions and zeros. So these are all called the same thing. They all mean the same thing. So if I say find the roots, find the x-intercepts, find the solutions, or find the zeros, that means to find the same thing. So it means that we need to set this equal to 0 and solve for x. So now we can set our factors equal to 0, x minus 5 equals to 0, x plus 4 equals 0. Right now these are our x-intercepts, so I'm just trying to find them. So x equals 5, x equals negative 4. So my intercepts are 5, 0, and negative 4, 0. And that's all it's asking you to do is to solve for x. And that's pretty much the same thing that we've been doing all along. If we pull x minus 5 out, this is kind of a proof showing that it is opposite when we pull it out of the parentheses. All right, so you try it for number 2. Pause the video and take a minute to solve number 2 and see what you get. All right, for this one, negative 3, because it does not have a variable, it can't be a solution, so it can't be a root or an x-intercept. So we only have to look at the values that have x in them. So right now, I'm only going to look at the factors, x plus 6 equal to 0 and x plus 5 equal to 0. So x equals negative 6, x equals negative 5. So my factor, or my x-intercepts, or my roots are negative 6, 0, and negative 5, 0. All right, next part, writing quadratic functions. We're going to write a quadratic function in standard form whose vertex is negative 3, 4. So now we have to decide what form are we going to use. So we have standard form. This says write a quadratic function in standard form, so we know that we're not going to use standard form to solve it right away. We're going to end up putting it into standard form. We have vertex form and we have intercept form. This one says whose vertex is negative 3, 4. So the best formula that we would be able to use to solve that would be y equals a x minus h squared plus k, your vertex form. So we're going to use the vertex form. We're going to plug in the vertex into the form, and we're going to solve, or we're going to convert it to the standard form. So for this, we're going to assume that a equals 1. Okay, so we don't have a value in front of the a. So y equals, we're going to plug in, this is our h, this is our k. So we're going to plug in x minus negative 3, which is plus 3 squared. And remember, k is what it is, so it's plus 4. Now to solve for that, we looked at this before. We have to expand this out. So we have y equals x plus 3 times x plus 3 plus 4. So x plus 3 squared means that I have to write that 2 times. Now I'm going to FOIL, so I have to FOIL this out. X times x is x squared plus 3x plus 3x plus 9. I can combine like terms. So I get x squared plus 3x, plus 6x, sorry, plus 6x, and then plus 13. So now I have this in standard form, y equals x squared plus 6x plus 13. So what I did is I converted from vertex form to standard form, because I could not go straight to standard form just by given only the vertex. So I had to use the vertex form for that to work. All right, looking at this one, it says write the function in standard form which passes through the points 2, 0, negative 4, 0, and has a point and passes through the point negative 3, negative 10. Well, I know these 2 points right here are my x-intercepts. So what formula, or which one of those forms do you think that we're going to use? Yes, we're going to have to use the intercept form, which is y equals a x minus p x minus q. So a times the quantity x minus p and x minus q. In this case, we're given an extra point. So because we're given this extra point, we know that a cannot be just 1. And so we have to find what A is. So we don't know A. Comma, we must find it. So this is what we're going to learn how to do today, is we're going to learn how to find the A and then convert it back to standard form. So y equals A, plug in what we know. We have our intercepts. So this is P, this is Q. We have x minus 2, x plus 4. Remember, it's opposite of what it is. Now we're given these, -3, -10. So we know -3 is x, -10 is y. I can use that and I can plug those values in to the equation for what they are. Y is -10. X is -3 minus 2. And -3 again, plus 4. So all I did was plug in my x and my y. I have -10 is equal to A, -3 minus 2 is -5. -3 plus 4 is +1. -5 times 1 is -5. So we're used to seeing it look like this. -5 times A is -5A. Solve for A. I divide both sides by -5. So then I get 2 is equal to A. Now that I know A is 2, I'm getting one step closer to standard form. So I can say that y equals 2 x minus times the quantity x minus 2 times the quantity x plus 4. All right, I'm going to do exactly what I did on the last one. I'm going to have to FOIL these together. So y equals 2 times the quantity x squared plus 4x minus 2x minus 8. Combine like terms. I get 2 times the quantity x squared plus 2x minus 8. And in order to completely get it to standard form, I'm going to have to distribute the 2 to everything inside the parentheses. So my final answer for standard form is y equals 2x squared plus 4x minus 16. And there you have it. I converted that all from intercept form to standard form. All right, last thing that we're going to look at is graphing and writing cubic functions using zeros. Cubic means you have an exponent of 3. So this one has an exponent of 3. That's a cubic function, which means we're going to have 3 zeros. Okay, so squared functions means we have 2 zeros, and now we're going to look in and have 3 zeros. So first of all, does this have a greatest common factor? If it does, let's factor it out. So if I look here, this has x to the third. That also has an x. So I know that I can at least take one x out. I'm left with x squared minus 4. Well, if you notice, x squared minus 4, this is the difference of two squares. X squared is a perfect square, 4 is a perfect square. So I can factor that even more into x minus 2 and x plus 2. Remember, it's the difference of two squares, which means I need two factors, one positive, one negative. Take the square root of each and put them in there. So now I have 3 factors. This one is a variable, so I can set this equal to 0, x minus 2 equal to 0, and x plus 2 equal to 0. Now that's x equals 0. This is x equals 2, and this is x equals -2. Now I have my 3 roots. And so now that I have those, I can graph them on the graph. So I know that this one's going to be 0, 0. This one's going to be 2, 0. And this one's going to be -2, 0. So let's plot those points on the graph because we need to graph the function. So 0, 0, negative 2, 0, and 2, 0. Well, we have 3 points that are on the x-axis. What good is that going to do us to make a graph? Well, it's not yet, but we still have a few things that we need to do first before we can finish our graph. So looking at the graph, the next step that we need to do is we have to pick up the value between the two x-intercepts. So if my x-intercept is here at negative 2 and my other one is at 0, 0, then I have to pick the point negative 1. And I'm also going to pick the point 1. So what I can do is I can make a table of values for x. I'm going to solve it at negative 1. And I'm also going to solve it at 1. I need to find the values when x is negative 1 and when x is 1 so that I can find the other points on my graph. So let's take negative 1 and we're going to plug it into our function. So remember f of x equals x to the third power, or x cubed, minus 4x. Plug that in, so negative 1 cubed minus 4 times negative 1. Negative 1 cubed is negative 1 times negative 1, which is positive 1, times negative 1 again is going to give me negative 1. Negative 4 times negative 1 is positive 4. So negative 1 plus 4 is equal to 3. So the ordered pair I'm going to graph is negative 1, 3. The next one I'm going to look at is when x is 1. So 1 cubed minus 4 times 1. 1 times 1 times 1 is still 1. Minus 4 times 1, which is 4. So this is going to give me negative 3. So my next ordered pair that I'm going to graph is 1, negative 3. So let's graph that. We have negative 1 and positive 3. So this is going to be negative 1 and positive 3 up here. And this is 1, negative 3 down here. Now I have some points that I can actually connect together. So let's make our parabola. Our parabola is going to come up. It's going to connect to this point. It's going to come down through 0, 0. Connect to the lower point, and it's going to come back up. This is the graph when we have a cubic function. So there you have it. It's like an S curve. All right. And then last, we're going to take a look at interpreting the parabolas. So just kind of reading the graph. Looking at this, I don't even need to teach you this. You could probably do this on your own. What is the maximum height of the ball? So if we look at here, it says about. Where is the maximum height? Well, we could say that it's about 9. We could say 9.1, 9.2, but we're just estimating. So it says, what is the maximum height of the ball? We're going to say about 9 feet. If you want to get technical, you could say 9.1, 9.2, wherever you think that might be at. All right, after how many seconds does the ball reach its maximum height? So I'm going to look. Its maximum height is here, right in the middle. So where is the axis of symmetry? It is at 4 seconds. What is happening at the point 8, 0 to 6, 0? So 6 zeros right here and 8 zeros. So if we look at what's happening from here to the bottom here, what do we know? The ball is dropping or falling. And hits the ball is falling at 6, 0 and reaches the ground at 8, 0. And how long was the ball in the air? Well, it started off at 0 and it ended at 8 seconds. So the ball had to be in the air for 8 seconds. All right, and then the last one we're not going to do because we've already done ones like this. This is an extra practice one if you want to work through it. Remember, the main thing is you need to find the x value. So the axis of symmetry using negative b over 2a. And then once you find what x is, plug it in to find what y is. So when is always your time, and what is always your height. Okay? All right, so that is it. I know these were some long notes today, but I hope you took the time to try and work through them and understand them the best that you can so that you're able to complete your homework. That is all. Have a great day, and I will see you guys on Thursday. A reminder that you do have a quiz on Thursday over vertex form and intercept form, so you may want to go back through those notes for vertex form so that you can do well on the quiz. All right, have a great day. I'll see you Thursday.